Today is going to be all about getting the database implemented. I have an initial database going where it is logging basically the sessions of everything that, like the drives that get connected. So every time a drive is connected, it logs that. It logs a bunch of metadata about that instance, and then same thing if you like remove the drive. So added, removed, drive information, how many partitions, files, partition table type, serial number, stuff like that. I need it to be much more robust. So I need a database that's going to have the static drive information, which is going to be like the serial number, vendor, and then I need session information. So each time that drive is connected or removed, that needs to be a separate table so it can log each session. So that's going to be every time it's connected, it gets a new session, drive was added, drive was removed. Here's the specifics of the drive in that session instance. So how many partitions were on there, what the partition table is, partition table ID, stuff like that. And then I need file system information because you can have multiple file systems for each partition table. So every time you connect the drive, it may have a different partition table. It may have different file systems. It may have the same partition table, but it may have different file systems. And so, or a different number of file systems. So that all needs to be recorded and documented with each instance. So I've got to have the static drive information. I've got to have session information every time it's connected or removed. File system information to go with each session. Tools, so if there was an execution or a task that was run, I need that to be a separate table so that it knows what tools were run with which session, with which drive, with which file system, all that stuff. And I need that tool to then record performance information so that I can track the performance of how these tools are doing just automatically over time. And that'll be extremely valuable in the long run. So I need to get that implemented as well. And then chain of custody. It doesn't have it yet, but it's going to have user accounts. So you'll be able to enter in your username, create an account, and then it'll be just stored locally. It's not going to be online, but you'll be able to create that locally and then log in, and it'll save your settings. Eventually, it's going to be where it saves your settings, your configuration information, your specifics, and so including your layout, stuff like that would be very cool. In the database, it needs to record the case number, the user that was logged in, that ran it. And I think that's it. So I'm just going to implement it gradually, start with the drives, start with the sessions, and then maybe the file systems, and then kind of expand it from there. But I need to get to where I can track performance data because that's going to be really valuable to me going forward. And it's all this stuff is going to be, at least the storing at the database is going to be something that the user can enable or disable. So if you don't want anything logged, the way that this will work right now, or the way that it's working, is when you connect the drive, there's a JSON structure that records all of the initial drive information, and that is just in memory. It doesn't get saved to the drive or written to a file or anything like that. So that's just stored in memory. And then to save it long term, it gets put into the database. So if you have the database disabled, it'll be a user setting, then no drive information gets saved to the file system, so to the actual unit, which is fine. Which is great. It's just another layer of protection. Sometimes people don't want anything written, so this will just keep it in memory and nothing gets written, nothing gets logged. So that'll be an option for users in the future. Now, like even if you are logging it, the drive is fully encrypted. So you can't pull the drive and access the data anyways. Like all the information is encrypted, and you will have the option to just delete the database if you want to, and it'll forensically wipe over the database records so that if somehow somebody were to get it and they were able to break the encryption on the drive, the data would still be wiped. So I'm building in all of these security mechanisms to make sure that people have as much control over their data as I can possibly give them. So that's today's task. Spent a little bit of time yesterday just having fun with user information. Oh, actually, the matrix screen working. I was just playing around with some stuff. But yeah, you can't see on this one, but the drive count is now on the screen on front, so you can just clearly see how many drivers are connected from source, destination, utility, all of the write blocking. So the write blocking is done at the kernel level, and so like for the source ports, like at the kernel level, it's read only. My initial implementation was when you connect a drive, there was a go routine that would set the drive immediately to read only, but the underlying kernel level implementation is much better. There's a couple other things that are done to make sure that the drive is read-only, that it's only mounted, auto-mounted, all that stuff's disabled. So I've about hardened the operating system as much as I possibly can to make it as forensically sound as possible. Yeah, that's where we're at today. And oh yeah. The screen also indicates read-only. So once it does that, once you connect to the source drives, it'll do its check to make sure that it's read-only. And then a little indicator will pop up that says write protected if that verification came back as yes, it is read only. So that's awesome. That's cool. It's nice to see that. And I think I'll probably implement like an initial systems check. I have a script now that I can test it with. So like once I build out the system, then I can go through like plug in drives into all the ports, and then I can run this check. It'll look at every drive and it'll go through each implemented write block feature that I have and check to see the status for all of those drives and give me a report. So I think I'll implement some kind of like basic check indicator when the system powers on. It'll just go through, hey, are all of these correctly implemented? And it'll give you like the thumbs up. Thumbs up, yeah. Once it starts, but I haven't done that. Eventually we'll get there. So yeah, that's where we're at today. I am happy with where it's at, making good progress, and just got to keep hammering away at it. So today's Saturday, tomorrow's Memorial Day. Probably do a few things tomorrow, but today's just get as much done as I can day. I think I've got the database structured and the plan. I've got a couple different plans. I got one from Gemini, one from Claude 4, and then one from Opus that was integrated with the code on VS Code. So I've got to review those, see which one I like the best, that I think will be the best way to go about implementing it, and we'll go from there and see where we end up. So, all right, happy Saturday.